Hello, my name is Mohamed. Today I will walk you through my project for Deep Learning Applications coursework. My project focuses on building a deep learning model to automatically classify sleep stages using EEG signals from the publicly available sleep EDF dataset. After I loaded my data and I imported my libraries, it was time for me to pre-process my data. First, I started by pre-processing the raw EEG signals from the PSG files alongside the hypnogram annotations for sleep stages. To do so, I used MNE, a specialized library for EEG processing, to read the signals and annotations and selects only EEG channels. Segment the data into 30 seconds windows as per sleep staging guidelines. Each 30 seconds window had labeled one of the 5 stages, which are awake, N1, N2, N3, or REM. After I extracted all the segments, I noticed class imbalance. Some stages had many more samples than others. To solve this, I used undersampling to balance the classes, making sure that each class had an equal number of examples. This helps the model avoid bias toward majority classes. Before feeding the data into a neural network, I standardized the EEG signals using standard scalar, ensuring the data is zero-centered with unique variance. This is crucial to help the model coverage faster and perform better. Moving to testing and training, I used 80-20 split, ensuring that the model was trained and validated on a separate data. And now moving to the big boy. For the model architecture, I built a convolutional neural network CNN, which is very effective for time series and biomedical signal classification. Our model consists of multiple 1D convolutional layers to capture temporal patterns, batch normalization for faster convergence, max poly layers for downsampling, dropout layers to prevent overfitting, and fully connected dense layers leading to the final classification output. I trained the model for 50 approaches with an early stopping mechanism and learning rate reduction during training. I monitored both training and validation accuracy and loss. The training achieved approximately 70% training accuracy after balancing the data. This shows the model was able to learn meaningfully features from the EEG signals, which I was very happy with. Unfortunately, the test accuracy was low, which I will explain why in the reports. After training, I evaluated the model using the testing set, a generalized classification report showing precision, recall, F1 score for each class. Additionally, I plotted the convolutional matrix to visualize the model's prediction against true labels, giving a clear picture of its performance across different stages. After training, I evaluated the model using a training set. I generated the classification report showing precision, recall, and F1 scores for each class. Additionally, I plotted the confusing matrix to visualize the model's prediction against the true labels, giving a clearer picture of its performance across different stages. Alright, and now moving to the main part of the video is how our model functions. So I made a very user-friendly website using Cradio. I made 2 websites. The first website allows users to upload a PSG EDF file and automatically convert it into NPY format to be ready for the prediction. This makes it easier for our model to predict the segments. So this is how it works. This is the first interface you see. This is the first page. Sleep staging pre-processing. I created here a small statement that said upload a PSG EDF file and automatically convert it to NPY EEG format for sleep stage prediction. You come here, you click on drop file here, you go to your PSG file. These green, the ones selected with green, they were never used in training or testing. It's a new file that we're gonna work with. We're gonna choose, for example, this PSG file, open. We're gonna wait for it to upload. It's gonna take a few seconds. All right, now that I uploaded, we click on submit. We wait for it to process. And here it is. It gives us the MP.wat file. We have the option to download it. If we click here, our files start downloading just here. While it's downloading, I will just show you here on the settings. You can choose either you want to display the theme, either lights, or you can choose dark or system. Also here, all the languages. For example, if someone speaks Arabic or anything, we can change the language just here. And that is the first website. Moving to the second one. And now with the second app, this is the main focus of this project. So this app basically helps us classifying the sleep stage from the MP.wat file we just converted now. So I'll just show you how it works. Same as the other, you import your MP.wat file here. Once the file is uploaded, the model will process each segment individually. So behind the scenes, the model loads the data, it applies any necessary reshaping, and then uses the trained CNN to make predictions for each segment. The results are shown just here. It counts how many segments were classified into each step. For example, in this example, it gives us 2,400 for wake and 1 for N1, which is the first step of sleep. Right, this is really useful for getting a quick overview of a subject's sleep structure without needing to manually label or interrupt EEG graphs. That was the end of my video. I'll load this video on YouTube. This is gonna stay forever for my kids. Hello my kids, after 20 years, this is your father. I was making this 20 years ago when I was studying. And yeah, thank you very much for your time, and I hope I get a first class mark. Bye bye, thank you, bye.